In 2008, a paper published under the pseudonym Satoshi Nakamoto began circling around the internet blogosphere in high-level tech circles. The author, or authors, we still do not yet know who exactly Satoshi Nakamoto is, outlined a vision for a purely peer-to-peer electronic version of currency. This new monetary system for the internet age would run solely by its own users verifying transactions, allowing it to be free of the third-party monitoring systems like central banks and governments that had long aggravated both libertarians and e-commerce entrepreneurs alike. 1 year later, in 2009, the first version of this currency was released as open source software to the World Wide Web, and the Bitcoin phenomenon began. Bitcoin itself is a topic rightfully worthy of its own study. This project, however, will examine blockchain, the consensus mechanism technology underlying the digital currency. Blockchain is a groundbreaking technology whose inner workings enable just what the Nakamoto clan had envisioned: transactions between unfamiliar parties across the globe, whose fairness are enforced by the fellow users on a network. Essentially, it is a massive running digital public ledger of every transaction ever made using Bitcoin. The ownership of any Bitcoin in circulation at any point in its brief history is available to the thousands of computers that make up the network. Any time a transaction is made, the payment and proof of transaction is recorded and cannot be erased. The true marvel of blockchain, or the qualities that make it such a secure and safe way of making online transactions, are how it records its data. Take a simple exchange of Bitcoin between party A and party B on the online platform. Keep in mind, these exchanges are done with the physical online currency of Bitcoin. Bitcoin itself is not backed by any precious metal or the dollar, pound, or yen. To give you an idea of its value, though, each Bitcoin in circulation is worth about 360 US dollars today. That can change based on a number of factors. So Party A proposes a transaction to Party B that will make Party A's Bitcoin wallet a little lighter and Party B's a little heavier. The entire Bitcoin network will then take a number of steps to ensure that this exchange is possible. One set of nodes, or a set of computers and their users on the network, will check to see if Party A actually has the amount of Bitcoin it wants to spend. If everything checks out, another group of nodes, called miners, will bundle Party A's proposal with other reputable transactions into a new entry on the blockchain. The data of all the transactions is boiled down through a hash function into a single string of numerical digits. The string of digits can be traced back to their hash, but the hash cannot be traced back to the digits. This means that if a dubious party tried to say, change the data, it would be clearly visible in the original hash. The hash is then placed on the header of a new block, a new addition to the general blockchain. Each new block becomes a complex mathematical puzzle that must be solved before the data of the new transaction can be connected to the existing data on the blockchain. The challenge to connect the new block to the existing block sees miners grind through trillions of mathematical possibilities, which can only be solved through trial and error. If one miner comes up with the correct answer to the puzzle, the other nodes check it for correctness before it is added to the chain. Here's the incentive: the winning miner is rewarded in Bitcoin for his efforts. His wallet then owns a little more of the finite Bitcoins in existence. How does this remarkable process enforce security and transaction integrity? For starters, it is impossible to tell which miner correctly solved the puzzle, which makes it very hard to cheat. More importantly, however, because of the way blockchain is designed, it is impossible for someone to go back and try to rearrange the existing data without the entire network noticing. Because each new block in the ledger is added onto existing ones, if a user tried to alter a transaction from, say, 6 months ago, it would disrupt every new entry made after it. For all these reasons, analysts have identified blockchain as a way of making and preserving truths on the internet. Blockchain is the only technology of its kind that ensures exchanges of property cannot be hacked. It also is a way of clearly identifying the assets of a certain party at any time, while making it impossible to steal or confiscate those assets. It is no secret, then, why the tech world has been scrambling to develop applications for blockchain. Banks are pouring millions into researching ways to make new businesses out of blockchain, and it has even been employed in democratic elections in some European countries as a way of ensuring security. It appears that what Nakamoto initially conceived of as a sort of libertarian holy grail, a way to move money around the globe anonymously, will be adopted by governments and the world's largest corporations for a number of purposes.